Okay, so let's get right into it. The engine that powers artificial intelligence, it is getting bigger, hotter, and way hungrier every single day. So what happens when planet Earth just can't keep up anymore? Well, a handful of the world's biggest tech visionaries are betting on a pretty radical answer. Just move it all into space. Yeah, we're talking about building the entire backbone for the future of AI in orbit.
So here's what we're going to cover. First, how is AI already helping us out in space? Then, why is Earth suddenly not big enough for AI's ambitions? We'll look at the actual blueprint for building this thing, and of course, the massive challenges it faces. And finally, we'll ask the big question, is the future of computing really orbiting above us? Now, you might think the idea of AI in space is some kind of far-off sci-fi concept, but it's not. It is happening right now as we speak. This image here really captures it perfectly. AI is already the silent partner in almost every single part of modern space exploration, making critical calls millions and millions of miles from home. All right, first up, let's talk about AI's cosmic helpers. Because, for decades, AI has been the secret weapon that's helped us tackle some of the biggest challenges of exploring space. I mean, just think about the sheer amount of data we get from space. Our spacecraft can pump out terabytes of information every single week. It's an absolute fire hose of data. There's just no way human scientists could ever sift through all of that manually. AI is the tool that lets us make sense of it all. And this is where it gets really concrete. AI is literally the smart driver inside rovers like Curiosity and Perseverance, helping them navigate the tough Martian landscape all by themselves. It combs through those massive data streams, looking for interesting patterns, it helps plan out entire missions, and it even keeps an eye on astronaut health. Oh, and it's also kind of like the traffic cop for our satellites, constantly crunching numbers to help them dodge the growing cloud of space junk up there. So that brings us to the real core of the issue, because as amazing as AI's current role is, its explosive growth is creating a problem that our planet might literally not be able to solve. So here's the key idea. What if the biggest hurdle for scaling up AI isn't the code or the processing power, but something much more basic? We're talking about physical, real-world constraints. Things like power, water, and just land. And this number, wow, it really puts the problem into perspective. By 2030, AI data centers could be demanding up to 100 gigawatts of power. I mean, that is just a staggering amount of energy, and our current grids might just not have enough juice to keep up. And this slide lays out the central argument beautifully. Here on Earth, data centers use enormous amounts of power and water, leaving a real environmental footprint. But the proposed orbital solution, it just flips that whole script. You get nonstop, 24/7 solar power, you don't need a single drop of water for cooling, and you take up exactly zero land. And this quote, well, it states the vision pretty plainly. The argument isn't just about what's happening in the next 5 years. It's the idea that for AI to reach its true, ultimate potential, it fundamentally has to leave the planet. So how in the world do you actually do it? Let's get into the blueprint and see how this grand vision turns into a concrete, multi-trillion-dollar engineering project. You better believe the money behind this is just immense. We're talking about a reported $1.25 trillion merger between SpaceX and xAI. The whole point is to create one single company that can do it all: build the rockets, launch the satellites, and run the AI. It's a massive attempt to control every single piece of the puzzle. The plan itself actually breaks down into 4 pretty clear steps. First, you launch new satellites, like Starlink's Gen 3, that are basically flying computers. Second, you power them up with these huge solar arrays. Then, you connect them all together with laser links that are actually faster than fiber optic cables on the ground. And boom, you've created a single, massive AI brain floating in space. And don't think this is all happening in some distant future. The first phase, the demonstration phase, is happening right now. Companies like StarCloud and Axiom Space are already launching prototypes. The plan is to move to early commercial operations in just a few years. And then, after 2031, you hit the growth phase, where the big cloud providers start moving their AI training into orbit. Okay, so the vision is grand, the engineering is ambitious, but even the best funded plans have to face reality. And in space, well, the laws of physics are completely non-negotiable. So the big selling point you always hear is about cooling. The argument goes that the vacuum of space offers natural or free cooling. I mean, it's cold up there, right? So getting rid of all the heat from those AI chips should be easy. Well, not so fast. Turns out it's not that simple, and it all comes down to something called the Stefan-Boltzmann law. See, in a vacuum, you can't use fans or water to cool things down. The only way to get rid of heat is to radiate it away as light. And it turns out that process is shockingly inefficient at the temperatures computer chips like to run at.
And this really drives that challenge home. Just to cool one pretty small 2-megawatt facility, you'd need a radiator with the surface area of almost 4,000 square meters. That is a massive, heavy piece of equipment you have to launch into orbit just to keep things from overheating.
And right here, this is the bottom line. With the cost of launching stuff into space today, building a big data center in orbit is just economically impossible. It's way too expensive. The entire business model, this whole grand vision, hinges completely on SpaceX's Starship bringing those launch costs way, way down to less than $100 a kilogram. If that happens, as this chart shows, the whole thing flips. It could actually become cheaper than building on Earth. So with all that in mind, the unbelievable potential and the absolutely immense challenges, where does that leave us? Let's take a look at the key players in this new space race and what's really at stake. I really cannot stress this enough. Every projection, every business plan, every single ambitious timeline comes back to this one variable. If launch costs don't absolutely plummet, this whole idea remains a tiny niche industry. If they do, well, it could change everything. And make no mistake, this is not a one-horse race. You've got startups like StarCloud launching powerful NVIDIA GPUs into orbit. You've got established players like Axiom Space deploying their first data nodes. Even tech giants like Google are getting in on it, testing their own custom AI chips up there. And there's a huge European initiative working on this too, to make sure they can control their own data in space. The field is getting crowded fast. So what are the big things to remember here? First, these orbital centers are really good at solving space-based problems, like processing satellite data on the spot. Second, they offer a potential way to get nearly unlimited clean power for AI. Third, and this is the big one, the economics only work if launch becomes radically cheaper. And finally, this isn't just a small upgrade. It's a total reimagining of where we do our computing. Which leaves us with one final kind of wild thought. For decades, the internet has been a thing of cables under the ocean and servers hidden away in buildings. But as we start to push the limits of what's possible here on Earth, you have to ask, is the next frontier of our digital world actually floating right above our heads?